Pollsters predict elections using sampling, which means measuring preferences in a small group and using statistics to infer what millions of voters will do. The core idea is simple. If the sample is representative of the people who will actually vote, then the sample's vote share is an estimate of the electorate's vote share, with uncertainty that can be measured. The first step is defining the population. Elections are decided by voters, not by all adults, so pollsters usually target likely voters. That already adds difficulty because turnout has to be predicted. Estimating opinions is one problem. Estimating who shows up is another. Next comes the sampling frame, which is the practical way pollsters reach people. This might be voter registration files, addresses, phone numbers, or online panels. Errors can appear here before anyone is surveyed. If some groups are missing or harder to reach, the sample starts biased. Then pollsters select respondents. In probability sampling, each person has a known chance of being selected, which allows standard statistical formulas. In non-probability sampling, like opt-in online panels, those probabilities are unknown, so pollsters rely more heavily on modeling and assumptions. Once contact begins, non-response becomes a major issue. Most people do not answer polls. Bias happens if responders differ from non-responders in ways related to vote choice. A low response rate alone is not fatal, but systematic differences are. To correct imbalances, pollsters weight the data. Weighting means some respondents count more than others because they represent more people like them. If a sample has too many college graduates, non-college respondents are given higher weights. Typical weighting variables include age, race, education, gender, and geography. Weighting reduces bias, but it also increases noise because large weights make estimates less stable. This leads to the idea of effective sample size. A poll might interview 1,000 people, but after weighting, it may behave statistically like a sample of 600. That matters for uncertainty. Vote share is then estimated as a weighted average of responses. Decisions about undecided voters and third-party voters can shift results by a few points. Polls report uncertainty using the margin of error. In simple terms, it reflects random sampling error. With about 1,000 respondents and a close race, that margin is around plus or minus 3 percentage points. But this number assumes the sampling frame, weighting, and turnout model are all basically correct. It does not include non-response biased, coverage errors, or late opinion shifts. Likely voter models add another layer. Pollsters use questions about past voting, interest, and certainty, or voter file data to estimate who will actually vote. Some models classify people as likely or not. Others assign each person a probability of voting and weight them accordingly. Small errors here can matter a lot, especially in close elections. Because any single poll is noisy, analysts usually combine many polls. Poll averages reduce random error, while more advanced models add structure to estimate results for states or districts. When polling misses, the problem is usually systematic, not random. Certain voters were missed, misweighted, or misclassified as unlikely to vote. Sampling works, but only when the assumptions behind it are close enough to reality. So polling is not magic. It is sampling, weighting, and modeling, used to estimate what a larger group will do, with uncertainty that can be partly measured and partly not.